Hi there, in today's video we're going to be looking at graphs of the form y equals a sin x plus c or y equals a cos x plus c. So basically today's video we're going to be given graphs that we know how to sketch, however there will be a number at the end of it. So for example it could be plus 2, it could be minus 3, something at the end of it, and we want to know what happens to the graphs when we have this case. So far what we know is how to draw or sketch graphs of the form y equals a sin bx or a cos bx. Okay, so when we have a letter at the front of our sin or cos, okay, and we have a letter attached to our x. Okay, so as a quick reminder, when we have a letter in front, so we call that a, then what the value does is it stretches the graph, or if the number is between 0 and 1, it will condense it, it will compress the graph and make it a bit squashier. So, for example, if we have just the normal graph y equals sin x, if we then put a 2 in front of it, so y equals 2 sin x, it means the graph won't go up to 1 and negative 1, it'll be stretched up to 2 and negative 2. Okay, so the value in front of the a tells you the heights of the graph and the trough of the graph as well, okay, the lowest part of the graph as well. The b value, which is next to the x, that tells us how many times this graph repeats itself in 360. So the normal graph y equals sin x or y equals cos x just has one complete cycle in the gap of 0 and 360. However, if we have sin 2x or sin 3x or cos 3x or cos 4x, then it means that it will repeat itself 3 or 4 times. So if it's cos 3x, it means we're going to have 3 cos graphs in the space of 0 and 360. So they are things that you should have seen before in the previous lessons and should have been practicing. What we're going to look at today, okay, is graphs of the form y equals a sin bx plus c or y equals a cos bx plus c. So we're adding a value. We've got our normal graphs that we've been looking at, but we're adding or subtracting a number from it. So c is just a value, okay, so it could be plus 3 at the end, it could be minus 2. We'll see what happens with that. So the question is, what does this c do? So what it actually does is it shifts the graph vertically. Okay, so at this point I'd write down this title and I'm going to write down this note here. So if we have a plus c, or a number at the end that we're adding or subtracting on, then the number at the end will push the graph up or down. That's what it does. So for example, if I have a graph like sin x and then I add 3 to it, it means I draw my normal sine graph, but then I shift everything up 3 spaces, okay, so everything goes up by 3, okay. Similarly, if I've got sin x minus 2, for example, then everything goes down 2 boxes once I've drawn my sine graph, okay. We're going to practice sketching a couple of examples of this. How I've described it is how we're actually going to sketch it. So for example, we're going to look at a couple of examples. Okay, I'm going to get you to copy these both down. The first one we're going to sketch is y equals 2 sin x plus 1. And how we think about it is the following. So I'll pause this video to make sure you're writing this down. Okay, the first thing we're actually going to do is we're going to sketch this bit here. So we're not going to worry about the plus 1 at the minute. Okay, we'll deal with that in a second. Okay, I want to know what 2 sin x looks like first. Okay, now I've got different colours on my device here, so I'm actually going to use different colours. If I was you, what I would do, if you only have the one colour attached to you, so for example using a pencil or just a one colour pen, is the first graph to draw a dashed line, okay, therefore it's not the final answer. Okay, I'm going to draw dashed lines too so you see what I mean, but I'm actually going to do it in different colours as well. If you've got to different colours, then it's a bonus. So we're going to draw y equals 2 sin x first. Now, we've got a 2 in front of the sin x, so that means my heights will both be at 2 and negative 2. So I'm actually going to add that on just now. Okay, it's just sin x, therefore I'm not needing to have more than one sine curve. Okay, it's not sin 2x or sin 3x's, okay, it's just sin x, so I've got one sine curve. So let me put on my data. I'm going to put my data in black in here so I can label my axis. So the origin 0, I'm going to have 180 there, 270 there, and 360 there. Okay, so what I'm going to do is I'm going to draw my sine curve, and again if I was you, I'm going to draw this dash, and it's going to be 2 sin x, so I've got my heights at 2 and negative 2. So it starts at 0, goes up, it curves back down when it's 180 down to 0, and goes down to negative 2 at 270, then back up to 360. So that is my curve there, y equals 2 sin x. What I want to do though is I'm now going to deal with the +1 part. Okay, so that means that every single part of the graph is going to get shifted up by 1. Okay, it's going to move up by 1. Okay, so that means that the starting point is not going to be there at 0. Okay, it's actually going to be at 1. So I'm going to put a wee dot there. The tallest part at 90 degrees was at 2 for 2 sin x, so it means it's going to go up 1, so it's going to hit the height of 3. At 180 degrees it's normally at 0, so it's going to go up 1 to 1 there. At 270 it's normally at -2, so it's going to go up 1 to -1, so I'm going to label -1 there. And then at 360 it goes, rather from 0, it's going to go up to 1. So what happens is I've now just got new points that my graph needs to go through. Okay, this is going to be my final answer, so I'm going to sketch this fully. Trying to go through as much of the points as I can. Okay, it's not going to be the best effort there, but hopefully you see that the normal 2 sin x graph in red there, I've just moved everything up 1. So my final answer is the one in black, which is y equals 2 sin x plus 1. Okay, so hopefully in that example it showed you the two parts to draw. The first part, then we'll deal with the shift after and get our final answer. Okay, we're going to move on to the next one now. So we're going to look at a second example where we have to sketch the graph y equals cos x minus 2. Okay, give myself a bit more space here. Oh, it's a bit jittery this thing. Let's try that. There we are. So we're going to draw cos x first. Okay, that's the first bit. Now the good thing is with cos x, this is actually just cos x. It's not 2 cos x, it's not cos 3x for example, it's just a cos x graph, the very first one that we've seen. Okay, so when it's just cos x, it's going to have a height of 1 and -1. Okay, I'm going to draw my numbers in my axis. Okay, so it's going to be 0 there, 90 degrees along there, it's going to be 180 there, 270 there, and 360 there. So cos graph, okay, cos graph starts at 1, so again this is going to be my final answer, so we'll draw this dash. Starts at 1 and then at 90 degrees goes to 0, goes to -1 at 180, up to 0 at 270, and back up to 1 at 360. Okay, so I've got my graph y equals cos x and dash there. So now I need to think about what this number at the end does to this graph. So because it is negative, it's going to shift it downwards. Okay, so it's going downwards and it's going to go down 2 boxes each time. So rather than starting at 1, if I go down 2, it's actually going to start at -1. Okay, at 90 degrees it was at 0, so it's going to go down to -2. So I'm going to label -2 there. At 180 it was at -1, it's going to go down to -3, so I better add that onto my graph. And then 270 was at 0, so it goes down to -2, and at 360 it was at 1, so it goes down to -1. So you're going to see I've got the same cost graph, it's just been shifted down to. Again, this one's going to be our final answer now, so let's see if I can draw that. Not the most curved, maybe that. Oh, that's in fact, I think I'm going to have a wee attempt at doing that again. That's actually a very poor effort. Let me just try my dots again. Watch this one will be washing out. Here we go, so it curves and then it goes up, back up there. Okay, so that is the graph y equals cos x minus 2. So there's two examples of when we have got a graph and it's shifting up or down vertically. Okay, today's lesson you're going to try and sketch some of these and be shown some of the graphs and try and work out what has happened to this. Okay, remember the two-step process where you draw the initial part. So for example, in example 1, you draw the 2 sin x graph first, and then you do the shift after. We went up 1. Second example, we drew cos x first, so we worked out what it looked like, and then we shifted everything down to, rather than trying to do it in one step. Okay, use the two-step process to make it more accurate. Okay, thank you for listening.